Not everything in science makes sense. Despite our satellites, supercolliders, and space telescopes, the universe still holds secrets that slip through our equations. Strange signals, impossible particles, stars behaving like they shouldn't, all of these are documented anomalies that defy our best models. And they're piling up. So today, let's take a look at 13 recent findings that scientists are still struggling to explain. Number 1. The Venusian Mystery, phosphine in the clouds. In September 2020, a startling announcement made global headlines. A team of scientists reported finding phosphine gas in the clouds of Venus. Why was this such a big deal? On Earth, phosphine is a rare gas that is almost exclusively associated with life or human industry. It's produced by certain microbes in oxygen-poor environments and by some industrial processes. It's not something that should be easily made in Venus's harsh atmosphere by known chemistry. Venus is often called Earth's sister planet in size, but its surface is hellish. Lead melting temperatures, crushing pressure, and sulfuric acid clouds. Yet about 50 kilometers up in the atmosphere, conditions are much milder. Temperate, though very acidic. Some scientists have long speculated that if life exists on Venus, it might float in those cloud layers. So, the detection of phosphine, a potential biosignature, was electrifying. Could it be evidence of aerial life in Venus's clouds? The initial data, though fascinating, was far from conclusive. The signal was faint and the analysis delicate. Critics quickly pointed out potential errors, including possible contamination from Earth's atmosphere or misidentified sulfur dioxide. The original team revised their numbers downward, but stood by their claim that something strange was in the Venusian skies. This sparked a wave of studies aiming to confirm or debunk the result. By 2021 and 2022, the story took new turns. Some independent research groups suggested they saw faint traces of phosphine as well, particularly when analyzing deeper layers of the atmosphere. Others still found no trace at all. A 2022 report indicated the gas might not be widespread, but could appear in specific altitudes or regions, perhaps varying with time. This gave rise to new theories. Could Venus have episodic phosphine production driven by volcanic bursts or atmospheric chemistry we don't understand? One thing was clear. No known process on Venus could easily account for the phosphine levels originally reported. Volcanic activity, lightning, or meteoritic input had all been considered, but none offered a satisfactory explanation. The alternatives are stark. Either there is a form of life surviving in Venus's acidic clouds, or there is a chemical process at work that we haven't yet identified. Either possibility is revolutionary, and this mystery has triggered a new wave of exploration. Missions from NASA and the European Space Agency are now planned for the 2030s. One of them, Da Vinci Plus, will drop a probe straight through the atmosphere, taking direct gas samples on the way down. Until then, the question remains suspended in Venus's thick clouds. Is it life? Is it chemistry? Or is it both, and something entirely new? Whatever the truth is, the phosphine mystery has breathed new life into the study of a world once written off, and it may be pointing us toward one of the most important discoveries of our time. Number 2. Deep Sea Enigma, the Golden Orb. In August 2023, deep beneath the Gulf of Alaska, a submersible's light swept across the ocean floor and caught something so peculiar. At a depth of 3,300 meters, resting on a rock, was a dome-shaped object with a smooth, golden surface. It looked organic, but alien. About the size of a softball, it had a small hole or tear near its top. The scientists guiding the remote-operated vehicle paused. One half-jokingly called it the beginning of a horror movie. They moved in, retrieved it gently, and brought it aboard. What followed was a rush of speculation. The Golden Orb, as it came to be called, baffled the marine biologists on board. It appeared to be biological in origin, but no one could confidently say what it was. Was it an egg? A collapsed sponge? A piece of coral? It had a soft, fleshy texture, and the single hole only deepened the mystery. The idea that something might have emerged or entered was hard to ignore. Photos circulated widely, and even experts couldn't agree on what category it belonged to. The deep sea often delivers surprises, but this one stood out. Back on the ship, scientists began testing the specimen. Initial results were inconclusive. One theory suggested it could be an egg casing of a deep-sea creature, possibly a sponge or invertebrate, damaged or partially decayed. Maybe the golden sheen came from biofilms or minerals in the water. But even then, it didn't resemble any known egg structure. Others suggested it could be the remains of a previously unidentified sponge, now shrunken and altered. Yet its symmetry, texture, and solitary location defied those assumptions. The discovery reminded the team just how unexplored our oceans remain. NOAA scientists noted how humbling it was to encounter something that eluded identification. In the deep sea, where light never reaches and pressure crushes most forms of life, bizarre organisms evolve in isolation. The orb might represent one such form, unseen until now. DNA testing is underway in a lab. If it matches a known species, the orb may be an odd growth form. If it doesn't, it could mark the discovery of something entirely new. Either result expands our understanding of life's diversity. The golden orb has captured public imagination not because it's deadly or massive, but because it's unknown. It's a rare physical mystery, something we hold in our hands, yet still don't understand. Until analysis reveals more, it remains a symbol of how little we truly know about the world beneath our oceans. Number 3. Flash in the sky. Fast radio bursts. In 2007, inside a remote observatory in Australia, a graduate student stumbled across a flash in the data, something brief, sharp, and utterly unexpected. It was a millisecond-long burst of radio waves, brighter than anything of its kind, and seemingly coming from far beyond our galaxy. At first, no one was sure if it was a glitch, but over time, more of these pulses were found, confirming they were real. They were dubbed fast radio bursts, or FRBs, and today they remain one of astrophysics' most confounding mysteries. FRBs are intensely powerful signals that last a thousandth of a second. In that instant, they release as much energy as the sun emits in several days. Scientists initially suspected they came from cataclysmic events, maybe a collapsing star or two neutron stars merging. But the discovery of repeating FRBs changed everything. One in particular, FRB 12102, was observed flashing multiple times, irregularly but persistently. If it repeated, it couldn't be a one-time explosion. This pointed towards something more stable, like a magnetar, a neutron star with a magnetic field so powerful it can crack atoms. Over the years, FRBs were detected across the sky, billions of light years away. Thanks to improved instruments, astronomers started tracing them to their host galaxies. Many came from small, active galaxies, consistent with magnetar theory. But anomalies began to surface. In 2020, one FRB originated from a large spiral galaxy in a calm region. Then, in 2024, a new FRB was found in an ancient galaxy, a place where no young magnetars should exist. These exceptions force scientists to consider whether multiple mechanisms might be producing these bursts. There were more surprises. One repeating FRB showed a 16-day cycle, active for a few days, then quiet, then active again. It hinted at a source orbiting another object or being periodically obscured. Meanwhile, in 2020, an FRB-like event came from within our own galaxy, traced to a known magnetar. This was the strongest evidence yet that magnetars could generate FRBs, at least sometimes. Still, the puzzle isn't solved. Why do only some FRBs repeat? Why do they come from such varied environments? Could they come from black holes or from phenomena we haven't imagined yet? FRBs are the universe's blink and you'll miss it messages. They remind us how much we don't yet understand about the cosmos. and how each new signal might contain the clue we've been waiting for. Number 4. The Interstellar Visitor, Oumuamua. In October 2017, atop a Hawaiian mountaintop, astronomers spotted something no one had ever seen before. A small point of light racing across the sky, behaving unlike anything local to our solar system. The object was soon named Oumuamua, which means scout or messenger from afar in Hawaiian. It was the first confirmed interstellar object ever observed visiting our solar system, a rare traveler from another star. But its foreign origin wasn't the only strange part. As astronomers tracked Oumuamua, they quickly realized it didn't behave like a typical asteroid or comet. It had no visible tail, no coma of gas. Yet as it passed near the sun, it began to accelerate, slightly but measurably. Normally, this sort of acceleration is caused by gas and dust venting from a melting comet. But Oumuamua didn't show any of those features. It was speeding up without a visible source of propulsion. This anomaly launched a wave of speculation. Some scientists proposed that Oumuamua could be made of unusual ices, like solid hydrogen or nitrogen, that would sublimate without leaving much trace. One theory published in 2023 suggested it might be releasing trapped hydrogen from deep inside, a process invisible to our instruments, but enough to explain the motion. Others wondered if it could be a fragment from a distant icy planet, something like frozen nitrogen from a Pluto-like world. And then there were the more radical ideas. What if this wasn't natural at all? Could Oumuamua be an artificial probe propelled by a light sail, drifting silently from another civilization? Despite the frenzy of theories, observations were limited. Oumuamua was already on its way out of the solar system when it was discovered. By late 2018, it had faded too far for our telescopes to follow. Scientists did manage to gather some details. It had a reddish surface. It tumbled chaotically, and it was likely very thin. But even its shape remains uncertain, either long and cigar-like or flat like a pancake. The acceleration remains unexplained. No firm conclusion has ever been reached. Oumuamua left us with more questions than answers, its secrets buried in the silence of space. Since then, astronomers have remained alert, hoping to catch another interstellar object in time. Some missions are even being designed to intercept the next one. Until then, Oumuamua is a cosmic riddle, a glimpse into the unknown that passed briefly through our skies, leaving behind only wonder and mystery. Number 5. JWSTs surprising galaxies. Too early, too bright. When the James Webb Space Telescope, JWST, began operations in 2022, astronomers expected breakthroughs. But what they found in its first year shocked them. JWST, capable of peering farther into space and deeper into time than any instrument before, began detecting galaxies that shouldn't exist. Some of these objects were seen as they were just 600 to 800 million years after the Big Bang, when the universe was a toddler by cosmic standards. And yet, they appeared fully grown. A 2023 analysis identified several bright red galaxies that seemed far too mature and massive for their age. Some held signs of stars that were already hundreds of millions of years old, implying they had formed even earlier. Others contained evidence of supermassive black holes, potentially a billion times the mass of the Sun. These galaxies weren't just faint smudges. They were surprisingly luminous, organized, and chemically enriched. Under current models of galaxy formation, this shouldn't be possible. Galaxies were supposed to form slowly, through gradual mergers and the slow buildup of structure. These appeared to skip those steps. To explain this, researchers are reconsidering the earliest chapter of cosmic history. One idea is that population 3 stars, the first generation of stars made entirely from hydrogen and helium, may have formed and died in rapid succession, kickstarting early enrichment. Another theory suggests that star formation in the young universe might have been far more efficient or intense than previously thought. More radical proposals point to adjustments in the physics of dark matter or the influence of a temporary burst of early dark energy that may have sped up structure formation. Some early candidates have been reclassified after further study, but many have held up under scrutiny. One of the standout examples, Glass Z12, sits at a redshift of 12.4, placing it among the earliest known galaxies, and yet it glows with a brightness that continues to puzzle scientists. What makes this mystery especially significant is that it challenges the standard model of cosmology, a framework that has worked for decades. Now, with JWST pushing observational boundaries, that framework is under pressure. The universe, it seems, got busy earlier than we thought. As JWST continues collecting data, we're witnessing science in motion. Each new image might demand another rewrite of our cosmic history. These early galaxies aren't just distant, they're disruptive. Number 6. Unidentified aerial phenomena, the Navy UFO encounters. In November 2004, off the coast of California, Navy pilots from the USS Nimitz encountered something that defied expectations. Their radar systems had tracked strange objects descending from high altitudes to near sea level with staggering speed. When two FA-18F jets were sent to investigate, they reported a smooth, white object hovering just above the ocean. No wings, no engines, just a tic-tac-shaped craft accelerating away at a speed no aircraft should be capable of. A targeting camera briefly locked on, capturing one of the most famous infrared videos in modern military history. This wasn't an isolated incident. Between 2014 and 2015, pilots from the USS Theodore Roosevelt, operating along the Atlantic coast, recorded similar objects, this time captured on FLIR cameras, in videos known as gimbal and go fast. These objects seemed to rotate mid-air, hover against headwinds, and fly without visible means of propulsion. The Pentagon confirmed all three videos were real and classified the objects as unidentified. What made these encounters difficult to dismiss were the multiple points of confirmation: visual sightings, radar data, and infrared imagery all aligned. Some UAPs appeared to plunge tens of thousands of feet in a second, while others jammed radar systems, a move considered hostile in military terms. Yet no one could explain what they were. In 2021, the US government released a report summarizing 144 UAP incidents. Of those, 143 remained unexplained. The report found no evidence these were secret US programs. And while adversary technology couldn't be ruled out, the performance characteristics seemed far beyond anything known. Safety concerns were noted, with military pilots worried about potential collisions. Some explanations lean towards sensor anomalies or visual illusions, especially in the case of the rotating gimbal footage or the speed illusions in Go Fast. Others argue the tic-tac was seen too clearly by too many credible observers to dismiss as glare. On the far edge of speculation, theories range from alien surveillance probes to physics-defying craft, while more grounded analysts consider undisclosed foreign technology or exotic atmospheric phenomena. By 2023, NASA and independent scientists began approaching the topic seriously, breaking decades of stigma. Still, data remains limited. For now, these aerial mysteries stand unresolved. They have reignited public curiosity and scientific interest alike, not because of what they prove, but because of what they refuse to explain. Number 7. Signals from the ice, the Antarctic particle mystery. In 2006, high above Antarctica, a balloon experiment called ANITA was listening for radio signals from cosmic rays slamming into Earth's atmosphere. But instead of detecting signals from space, it caught something completely unexpected, a radio burst from below, as if a particle had erupted out of the ice. At first, the team suspected an error. Then, in 2014, it happened again. These rare upward-pointing events defied explanation and hinted at a strange possibility: new physics hidden under the ice. Here's why it's odd. The signals resembled what you'd expect from a tau neutrino, a high-energy particle capable of passing through Earth and decaying into a spray of secondary particles. But tau neutrinos at those energies are supposed to be absorbed by Earth, not make it all the way through and back out again. The steep angles of the events made it even less likely they came from regular neutrino interactions. It wasn't impossible, but it was statistically improbable. And two such detections? That didn't sit right. Scientists considered exotic explanations. Perhaps sterile neutrinos, hypothetical particles that barely interact with matter, were responsible. Or maybe heavy supersymmetric particles, unknown cousins to the ones we know, could survive the journey and decay upward. Some even floated the idea of exotic physics like axions, where particles interacting in unknown ways. Media headlines exaggerated one fringe theory, dubbing it a parallel universe discovery, but that was a distortion of the real scientific caution surrounding the event. The truth is, no explanation fits easily. The ANITA team ruled out common causes, signal reflections, instrument glitches, atmospheric anomalies. Nothing matched the data. Meanwhile, IceCube, another detector embedded in Antarctic ice, hasn't seen events like these, adding to the confusion. If these particles are real, why hasn't IceCube caught them? In the 2020s, researchers checked data from the Pierre Auger Observatory in Argentina. Again, nothing. But that absence mattered. It helped eliminate standard neutrino behavior as a cause. Whatever ANITA detected, it doesn't match what we expect from particles we know. Now, scientists are building PEUO, a more sensitive follow-up to ANITA. It will fly with better instruments and gather more data, perhaps enough to solve the mystery. Until then, those two strange signals remain unexplained. This puzzle reminds us that even in the most remote corners of our planet, we might stumble upon clues that point to entirely new laws of nature. The Antarctic ice may be whispering secrets from the edge of physics. We just haven't cracked the code yet. Number 8. The case of the Hubble constant, a cosmological tension. How fast is the universe expanding? It seems like a simple enough question, but it has sparked one of the deepest mysteries in modern astronomy. The number that answers it is called the Hubble constant, and recent measurements using different methods have come into sharp disagreement. This isn't just a rounding error. It's a clash that suggests something in our understanding of the cosmos might be fundamentally off. There are two main methods for measuring the Hubble constant. One looks at the nearby universe. Astronomers use what's called the distance ladder, where they observe well-known stars and supernovae to calculate distances and match them to how fast galaxies are moving away. This approach, backed by high-precision work from teams using the Hubble Space Telescope, gives a value around 73 kilometers per second per megaparsec, meaning for every megaparsec, about 3.26 million light-years of distance, galaxies are receding 73 kilometers per second faster. It's a well-tested technique with low uncertainty. The second method looks at the early universe, specifically the cosmic microwave background, the afterglow of the Big Bang. Data from the Planck satellite, when plugged into our best cosmological models, gives a smaller Hubble constant of around 67 kilometers per second per megaparsec. Other methods using large-scale structure and sound waves from the early cosmos agree with that lower figure. This mismatch between the now and the then is called the Hubble tension. At first, researchers suspected an error in the data, but teams have double-checked their work repeatedly. The error bars are small, and the disagreement is real. If these results both hold up, it could mean our current model of the universe, called lambda CDM, is missing something important. Possibilities include an unknown type of particle in the early universe, or a strange form of dark energy that evolves over time, altering the expansion rate. Some recent studies using JWST data have produced values closer to the middle ground, around 69 or 70, but the gap isn't closed yet. Until it is, the tension remains an open wound in cosmology. It's not just about a number. It's about whether we truly understand how the universe behaves at the largest scales and earliest times. Solving the Hubble tension could require new physics, or it might simply reveal hidden flaws in one of our methods. Either way, it's a rare and exciting moment, a reminder that even the most basic cosmic questions can lead us straight into the unknown. Number 9. Weighing the W boson. A particle that didn't fit in early 2022, a shockwave rippled through the world of particle physics. The CDF collaboration at Fermilab released a new, ultra-precise measurement of the W boson's mass, one of the fundamental particles responsible for the weak nuclear force. What caught everyone off guard wasn't just the precision, but the result itself. The W boson appeared to be significantly heavier than expected. Not slightly off, but wildly so. By over 7 standard deviations. That's a gap too large to dismiss, suggesting either a major error or a glimpse at physics beyond what we know. The Standard Model, which governs our understanding of particles and forces, has predicted the W boson's mass with remarkable accuracy for decades. CDF's result didn't just challenge it, it tore at its foundation. If the W boson really is that heavy, then some unknown force or particle must be skewing the numbers. Immediately, theorists jumped on the anomaly. Maybe there are hidden particles influencing W boson properties. Maybe an undiscovered symmetry is at play. The excitement was palpable, but there was also caution. Measuring the W boson's mass is no easy feat. It involves sorting through massive amounts of collision data and correcting for countless variables. Other experiments have tried, and their results didn't match CDF's bold claim. The CMS collaboration at CERN published its own W boson measurement in 2023. It aligned closely with the Standard Model. The ATLAS experiment, too, reported values consistent with previous expectations. So now the physics world faced a new kind of puzzle, a lone outlier. Was CDF right and everyone else missing something? Or did a subtle systematic error slip into CDF's data despite the years of rigorous work? Scientists began double-checking every calculation and every assumption. The debate wasn't just about numbers. It was about whether one of the most trusted models in science might need rewriting. As of now, the W boson mystery remains unresolved. New analyses are underway. ATLAS is preparing another high-precision result. Theorists are revisiting models, trying to account for CDF's data without tossing out the entire Standard Model. This is science in motion, uncertain, rigorous, and thrilling. If CDF's result holds, it could mark the beginning of a new era in particle physics. If not, it will serve as a reminder of how complex the pursuit of truth can be. The weight of the W boson, quite literally, still hangs in the balance. Number 10. Mars methane, a faint whiff of life. Mars has always whispered promises of life. Dry riverbeds, strange rock formations, and ancient lake beds have hinted at a wetter past. But in recent years, it wasn't the ground that got scientists excited, it was the air. More specifically, a fleeting trace of methane. On Earth, methane can be geological, but it's often biological. It doesn't last long in the atmosphere either. Sunlight breaks it down in just a few centuries. That means if you find methane on Mars today, it was likely released recently. And that opens the door to possibilities we're not yet ready to close. NASA's Curiosity rover, rolling through Gale Crater since 2012, has a tool to sample Martian air. It has repeatedly detected tiny puffs of methane near the surface, sometimes steady, sometimes with sudden spikes. The levels are minuscule, but their presence is real. These spikes were so unexpected, the Curiosity team triple-checked everything. It wasn't a malfunction. Something in that crater, somewhere beneath the dust, was releasing methane into the Martian sky. But then came confusion. The Trace Gas Orbiter, a satellite circling Mars since 2016, was built to detect methane globally and with far greater sensitivity. Yet it found none, not a trace. The readings from orbit and surface didn't align. It was as if Curiosity had caught the smell of smoke, but the satellite saw no fire. The contradiction became one of the most perplexing puzzles in planetary science. One possible explanation is that methane on Mars hugs the ground, pooling during the cold, still Martian night. By day, sunlight breaks it apart or disperses it before it reaches higher altitudes. The orbiter might simply be missing it. In 2021, Curiosity confirmed that methane readings were slightly higher at night, supporting this theory. But even that doesn't explain where the methane is coming from, or why it comes in bursts. There are theories. It could be geology, underground rocks interacting with water, releasing gas through cracks. Or maybe frozen clathrates, methane trapped in ice, are slowly venting. Then again, it could be life. Not intelligent life, but ancient microbes buried deep beneath the surface, eking out a living in dark, salty brines. The data isn't conclusive, but the possibility remains alive. The methane mystery persists. No consistent pattern, no clear source, just occasional hints, whispers, and traces. But in science, a trace is enough to keep searching. On Mars, even a faint chemical scent can stir the imagination and maybe point to something waiting in the dust, just beneath the surface. Number 11. The muon secret, muon G2 anomaly at Fermilab. Just outside Chicago, a ring-shaped experiment has taken center stage in one of modern physics' strangest stories. It's called muon G2, and it aims to measure the magnetic moment of the muon, a heavier, unstable cousin of the electron. In theory, the muon's magnetism should line up neatly with predictions from the Standard Model, the reigning framework of particle physics. But in reality, something appears slightly off. The number doesn't quite match. And that tiny difference could signal a crack in our most trusted theory of the universe. The saga began at Brookhaven Lab in the early 2000s, where a precursor experiment hinted the muon's magnetism didn't behave as expected. It was just enough to spark interest, but not enough to claim discovery. Then came 2021. Fermilab's muon G2 confirmed the anomaly with greater precision. The muon's magnetic wobble, expressed as the value G2, wasn't aligning with what theory said it should be. The discrepancy was small, but statistically significant. Excitement erupted. Some physicists began to whisper, "New physics?" By 2023 and 2025, Fermilab had refined its results even further, reaching a stunning precision of 0.20 parts per million. The data remained consistent, but a twist emerged, not in the lab, but on the chalkboards. The theoretical calculation of the muon's magnetism turned out to be staggeringly complex, pulling in effects from nearly every particle and force known. Two approaches emerged, one using traditional data inputs, the other using lattice QCD, an advanced computational model. The newer method brought the theoretical prediction closer to the experimental result, shrinking the gap that once suggested new physics. So now, in 2025, the mystery is murkier. The experimental result is sound, but the theoretical prediction may have been flawed or incomplete. Maybe the anomaly was a mirage, born of a miscalculation. Or maybe, just maybe, there's still a real difference hiding in the math, a whisper from beyond the Standard Model. Either way, the muon G2 story has reinvigorated particle physics. It sparked wild speculation, galvanized new calculations, and pushed precision to its limits. Japan may soon run its own version of the experiment to cross-check the result. For now, the muon remains enigmatic, its strange magnetic moment a lingering question in the search for new physics. And whether it leads to a breakthrough or a deeper appreciation of what we already know, it's a thrilling ride. Number 12. The dimming star, Tabby star. In the constellation Cygnus, a quiet star has been misbehaving in ways that left astronomers grasping for answers. KIC 8462852, more widely known as Tabby star, first drew attention in 2015, when data from the Kepler Space Telescope showed it dimming in strange, irregular patterns. These were not small flickers. Some dips in brightness reached nearly 20%, far too deep to be caused by a passing planet, and they didn't follow any predictable pattern. It was as if something enormous, irregular, and shifting was repeatedly passing in front of the star. At first, speculation ran wild. The leading astronomer on the case, Tabitha Boyajian, tried to rule out the usual suspects: planets, star spots, comets. None of them explained the magnitude or frequency of the dips. The public seized on a far more dramatic theory: an alien megastructure. The idea of a Dyson swarm, a collection of solar collectors orbiting the star, caught headlines around the world. It was never a serious contender among scientists, but the very fact that no natural explanation fit neatly was enough to keep the mystery alive. Years of follow-up observations began to paint a more grounded picture. By 2018, spectral analysis revealed that the star dimmed more in blue wavelengths than red, a telltale sign of dust. Tiny particles can scatter light unevenly across the spectrum, and this wavelength-dependent dimming pointed towards something more natural. Researchers suggested a cloud of fine-grained dust, likely the result of a shattered object in orbit, such as a moon or icy planet. a family of disintegrating comets, was another candidate. By 2019, data from NASA's Spitzer and Swift telescopes supported this theory. The dimming events didn't appear uniformly across the electromagnetic spectrum. That, combined with a lack of excess heat or infrared radiation, suggested the objects blocking the star's light were small, cool, and translucent, characteristics that align with a diffuse dust cloud rather than a solid megastructure. Still, the story isn't over. The star's slow, long-term fading remains unexplained. The dips haven't stopped either. They continue at irregular intervals. Though less dramatic than before, whatever is happening around Tabby's star, it's not a stable structure. It's dynamic, possibly chaotic, and still not fully understood. What makes this mystery special is how ordinary it looked at first. A star much like our sun, quietly hiding something strange. Tabby's star reminds us that we don't yet understand every mechanism in the cosmos. It may not be aliens, but it's still unexplained, and that keeps the telescopes pointed its way. Number 13. The search for Planet 9. The outer edge of our solar system may not be as empty as once thought. For decades, astronomers assumed the known planets and icy leftovers like Pluto were all that remained beyond Neptune. But a quiet mystery has been building. Several distant icy bodies, objects far beyond Pluto, aren't just scattered randomly. Their orbits show strange alignments. This unexpected pattern led two astronomers, Konstantin Vatigan and Mike Brown, to suggest in 2016 that an unknown planet might be shaping those paths. They called it Planet 9. Unlike Pluto, Planet 9 wouldn't be a small frozen relic. It would be a true planet, possibly 5 to 10 times Earth's mass, orbiting a staggering distance, perhaps over 500 times farther from the Sun than Earth. If it exists, it's likely cold, slow, and dim, which would make it nearly invisible to current telescopes. Its gravitational reach, however, could still pull on other bodies in the distant solar system. And that, scientists believe, might be what's causing a handful of trans-Neptunian objects to cluster in a way that shouldn't happen, by chance. The idea gained traction because it made testable predictions. It explained the odd behavior of objects like Sedna and others whose orbits swing them far away from the Sun in coordinated directions. Simulations showed that a hidden planet with specific traits could cause these groupings. Over the next few years, more distant bodies were discovered. Many of them fit the predicted pattern. Still, critics pointed out that observational bias might be at play. Telescopes don't scan the sky evenly, and we might just be spotting things where we're looking the hardest. That could make the clustering look more real than it is. The search is ongoing. Observatories like Subaru in Hawaii have combed the suspected regions, scanning star fields for anything moving slowly enough to be a distant planet. So far, nothing confirmed has emerged. Some false positives, a star or galaxy mistaken for a planet, were ruled out. New tools, like the Vera C. Rubin Observatory, could soon tip the scales. Its wide-field, deep surveys may reveal Planet 9, or finally prove that it's not hiding out there. For now, the solar system's frontier holds its breath. The evidence remains circumstantial, but stubborn. Whether Planet 9 is real or the result of a misread signal, the mystery has revived the spirit of exploration that drove earlier planetary hunts. Something out there is shaping distant orbits, and we haven't found it yet. From distant galaxies that shouldn't exist to rogue signals under Antarctic ice, the universe is reminding us that we don't have all the answers. In a world driven by data and precision, these mysteries stand as stubborn reminders that the frontier of science is still wild. And that's exactly where discovery begins. If your mind was blown by the strange and unexplained, don't let the questions stop here. Hit that subscribe button and join us as we dive deeper into the secrets science still can't yet explain. More cosmic riddles, more unsettling truths, and more mind-bending facts are just one click away. Stay curious, stay questioning. We've only scratched the surface.